Okay, everybody, very good. I appreciate that. Thanks for joining me today. As usual, we have very little time. I was hoping for a few hours. They did not in reality actually give me a few hours. So we have very little time and a lot to get through. Before we get too far down the road, I want to encourage you to join my masterclass thing. Is that possible? Can they register for that thing later? They can. So join my masterclass session thing, which is on one of the days between now and the end of the conference, or maybe it's just after the conference. I don't know. That'll be fun. That's like 8 hours of stuff. So join me for that. It's on the schedule. I don't know when the actual proper date is. But that said, we do have a lot to get through in the next, whatever it is, 50 minutes. So I want to encourage you, as always, to take note of the stuff in the slide, for your own edification, for your own reference for later on. There you'll find, first of all, chief among the things you see on this slide, you'll find the code that we're going to go through today for your own reference, for your own edification. And you're going to find my coordinates online. So if you should have questions, when you have questions, don't hesitate to find me online. I'm happy to answer. Obviously, I'm on Twitter. Just curious. I'm always curious about this. How many of you, by show of hands, are on Twitter? Twitter? Okay. The rest of you, get on it. It's a great place to be. It's the new IRC. It's where all the developers that drive the open source that powers your businesses are. So do that. What about email? What about emails? Anybody here on email? Email. No, good, moving on. I'm not really a big email fan, although if I'm honest, I much prefer it to Slack, right? I've got a friend, James Ward, that said that while he's not entirely sure, he suspects that based on CPU activity alone, Slack is mining for Bitcoin, something that I expect is probably true. Okay, a little bit about me. My name is Josh Long. I'm a Spring developer advocate on the Spring team. I'm on WeChat. For those of you who are in China, you're not, it's Chicago, but that said, I have videos on Safari, a lot of different videos. These are all like 5, 6, 7, 8 hours of different content detailed sessions on these different things. I've got a book called Cloud Native Java that's now available in a proliferation of different languages. I do a podcast every Friday called The Beautiful Podcast, which is available wherever fine podcasts are purveyed. I do screencast every Wednesday called Spring Tips, which is me diving into some corner of the Spring ecosystem. These are, me at a keyboard doing a hot take 30 minutes to an hour on a given topic, a very focused, specific look at a particular topic. And of course, I've got a new book on which I'm working, which is now available for pre-sale, and you can already start reading it now. It's called Reactive Spring. And this book looks at a lot of the stuff that we're going to focus on in this session. It's a look at how to build applications that take advantage of reactive programming through the lens of the Spring ecosystem. And this book is, I think, the longer form of what we're going to talk about today. So maybe I've just negated your need to buy the book, but it's okay. It's worth understanding that reactive programming is a new response to an old problem. That is to say, the question that people struggle with these days as they move to microservices, as they move to big data, as they move to IoT, Internet of Things, and to NoSQL, and to these scenarios where they're conducting increasingly large amounts of data over the network, the question that they struggle with is, how do I scale that out? And the reason that they start to appreciate that this is difficult is because a lot of the traditional approaches to doing input and output with which we're familiar starts to crumble in the face of this new scale. What do I mean by that? Well, suppose you have a traditional JVM-based application using Java I/O input streams and output streams. You've got a server socket parked on port 8080, and you're waiting for the next connection to arrive. When the next connection arrives, you want to produce a response. So you get the input stream, you produce some bytes, and you send it on the output stream. What happens in that span of time? Well, the client thread on which all that input and output is happening is blocked. You're not able to do anything with it. So how do you scale that out? You create new threads. Is that an infinitely scalable solution? Can you just create new threads in perpetuity on the JVM in 2019? TLDR, no, right? You can't do that for a number of reasons. First of all, threads are expensive. They have about a megabyte of state that's associated with bookkeeping, with the managing of the native process and the operating system that's managed by the operating system. Not process, but the thread. That's the first thing. It's expensive. So if you have 1,000 threads, which is a crazy high number, but suppose you had 1,000 threads, you'd have an extra gig of RAM before you've done anything. Just as the JVM starts up, you've already got that, right, for each thread you've created. Now, could you actually schedule 1,000 things discretely at the same time per second? Well, of course not, right? Unless you have 1,000 cores, which is, as I understand it, just enough to run Slack. Unless you have 1,000 cores, that's not going to be great. It's not going to be what you expect, because what you have is scheduling. It's an illusion. You're moving work from one CPU to another, one core to another, hoping to be able to simulate the illusion of 1,000 things happening at the same time. But that's not real. So the question is, how do I handle 1,000 requests at the same time? And the clear answer is that we can't do it with threads. So the pragmatic answer, something with which we're all, I expect, no doubt familiar, the answer that has emerged in the last 10-odd years in the move to the cloud, this exodus to the cloud, is you just scale out horizontally. And this is a very pragmatic answer, right? We've all talked about 12-factor microservices and cloud-native applications, and this idea that you remove as much state, as much cost associated with scaling out a horizontal ensemble as possible, right? We talk about the cloud-native architecture, right? This idea that you can put a bunch of stateless web servers into a load balancer and then just start distributing load across them, right? Either web servers or Kafka consumers or something. Either way, you're scaling out horizontally. And the cost of doing so, because you have no state to replicate, is cheap. It's nil. They're all idempotent, basically. They're all stateless. So this is a pragmatic approach and allows us to get to the scale that we need to get to without making any hard concessions. This is certainly a worthy option, especially if you have code written in yesteryear that doesn't do better than what we want it to do, but it's a little expensive, it's a little inefficient. We can do better. One way to do better is if we can find opportunities in our code itself where we are doing something inefficient. That is to say, where we are denying ourselves the opportunity for scale. One place where we might be doing that is with input and output. Right? That input and output, it takes a long time. And when we're sat there on that thread doing that input and output, we can't reuse that thread. We can't repurpose it. And the reason is because as we're doing reads and writes with those input streams and those output streams, we're sitting there waiting for the bytes to come. Where's the next byte? Come on, I gotta go, come on. Right? We're queuing, waiting for those bytes to arrive. That delay means that that time that we're spending there on that thread is wasted time. Because a lot of times, it's not that the bytes aren't there, it's just that there's a network outage, or there's a delay, or some sort of failure, or something like that, right? It's not that there's just a huge amount of data. A lot of times, it's just the sort of uncertainty of the network. So we've got this distributed system, and we're experiencing uncertainty. Who could have predicted this, right? So the question then is, how do we build systems that don't waste time waiting for bytes when they're not there, and allow us to repurpose those threads? If we move to asynchronous I/O, we can do this. Asynchronous I/O is kind of like synchronous I/O. You get data in, you can send data out, except that with asynchronous I/O, you ask for the data, and then you get an interrupt, a callback later on when the data is available. This allows you to make the request and then immediately move off of the thread. As soon as you've made the request, the bytes will come later, but in the meantime, you're going to get off that thread and allow somebody else to use it, right? And because of this, you're not sitting on any thread for more than a few milliseconds, hopefully. This allows you to handle more requests, because you can handle more incoming requests and start the process of waiting for bytes. And then you ask the operating system to actually manage that dispatch, the managing of incoming streams to user code. That can be done much more scalably than us in our user code creating threads to do that waiting. That scalable process allows us to handle thousands of requests per second. Right? And if you've ever seen the C10K problem, this is the problem of how can I handle 10,000 concurrent requests at the same time? You can't do it with threads, but you can do it with this. If what you're doing is I/O bound, if what you're doing is limited based on your ability to do input and output, and you move to asynchronous I/O, then you can reasonably expect to scale to those kinds of levels. This is not a new idea, right? Asynchronous I/O has been around for a long time. It's been around for decades in all the major operating systems. It's so prolific and so obviously useful that it's been in all the major operating systems for so long that it has in turn also been in Java since Java 1.4. Java 1.4 came out in 2002, in the very beginning of the year. It's been more than 17 years. When it's in Java, that means there's a way to do it in a consistent way across all the operating systems on which Java runs, even Windows. Windows. Imagine. So the point is, we've got this thing in Java 1.4. We've got it there since 17 years ago. Are we all writing code using Java NIO? Do you all write code using Java NIO? And I expect that the answer is no, of course not. You're not going to write code using Java NIO, because most of us don't spend our time at that low a level. We don't think about the code in terms of input and output for synchronous or asynchronous code. right? We don't write our code in terms of Java I/O input stream and output stream either. No, no, no. We think about the world in terms of computational metaphors that allow us to map our business domain to the underlying input and output abstraction. In most of our code, that abstraction, that metaphor, is something like a Java collection full of type T, where T is your business entity. And you use technologies that support these abstractions, things like Spring and Hibernate. But imagine that we had a new metaphor that supported this new asynchronous, this new potentially unbounded world. That metaphor would need to be pervasive. Everything that we do would need to be able to support that metaphor. And this is why it's very important that we have something that everybody agrees on. Imagine, for an instance, just suppose, just a hypothetical, that for whatever reason, 10 years ago, these technologies with which you were familiar, that you had become accustomed to using, these technologies that supported what you're trying to do, technologies like Hibernate and Spring, imagine that for whatever reason, they were just really hostile, just absolutely hostile to Java util collections. Right? Imagine that when you tried to do a one-to-many relationship in your Hibernate entity, and you used a Java util list type, an array list, for example. Imagine that for whatever reason, whenever you used a Java util list subtype or Java util collection subtype, for whatever reason, you didn't just get an exception on the console. No, 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 no. It actually printed an ASCII art middle finger and then segfaulted the machine, right? Would you continue to use this if you knew you could expect that kind of abuse? Would you continue down that path if you knew that was the result? And the answer, I think, is of course not. You'd use whatever Hibernate told you to use to get to the desired result. You're not going to stop shipping software, right? If the path of least resistance is to use this new thing called a Hibernate list thing, whatever, then you're going to use that because that gets you to production. And that's what matters here. So the same thing is here true with the reactive sort of types that we need, these types that allow us to map this asynchronous I/O. Whatever we choose, whatever we depend on, has to be supported across all the different technologies that we care about. And so this is why in 2015, a number of different organizations, the people on Pivotal, where I work, we're part of that's the lead sponsor of Spring, the people at Netflix, the people at ASCII, Lightbend, TypeSafe, the people at the Eclipse Foundation, and a number of others, we all got together and we created something called the Reactive Stream Specification. The Reactive Stream Specification are just 4 very simple types, and they provide these very, very simple types that allow us to describe potentially unbounded, asynchronous, latent streams of data. They're so obviously useful, these types, that they have been since incorporated into the JDK. They're in Java 9 now. So these types are very, very useful. They fill a particularly significant hole in the JDK that was at that point unplugged. On top of which, there's still a need for some operators to support streaming of data, processing of data. How do you map over data? How do you filter it? These kinds of things. So we have projects like Reactor and RxJava 2 and ASCII streams and so on. These different projects sit on top of that layer, providing these operators. They all speak these reactive streams types. They all understand these basic types, but they go a level further, providing pipelines. And on top of that, well then what? Are we done? Can we go home yet? And I'd say the answer is still no. What good are these types if the frameworks, if the technologies with which we work don't understand them? And so this is why the big sort of the big moment for all of us on the Spring team was in September of 2017 when we released Spring Framework 5. The first release to support natively Project Reactor and the reactive streams types that I just described. On top of which, we have since released Spring Data K, Spring Security 5, Spring Boot 2.0, Spring Cloud Finchley, and so much more. So what we're going to do today, my friends, is we're going to look at that journey. We're going to write code that takes advantage of this sort of holistic approach to building reactive applications. And we're going to do that, of course, at my second favorite place on the internet. My second favorite place on the internet after production. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather is amazing. It's the happiest place on earth. It's better than Disneyland. But if you haven't already been there, you can begin your journey here at start.spring.io. If you need inspiration in the early morning before a cup of tea or coffee, preferably purchased here at Intelligentsia Coffee, start.spring.io. If your children are restless and can't sleep, start. That's spring.io. And if you suffer from indigestion after a long night of alcohol abuse and PHP, start. That's spring.io. So what we're going to do is we're going to build a new application, my friends. We're going to take advantage of the latest and greatest Spring Boot snapshot releases because YOLO. We're going to build a new service called the Reservation Service. We're going to use the dependencies that we want. I'm going to choose more options to bring in Java 11. This is really the only sane choice these days. I can't wait for the day when this is the default. We're going to bring in the reactive web support. We're going to bring in Lombok. We're going to bring in the dev tools. We're going to bring in the reactive MongoDB support. We're going to use RSocket. And I think that's it. I think that's probably enough for our purposes here and now. That said, there's other things we could elect to include, and I encourage you to take a look at that list at your own leisure, at your own discretion later on. You can just do that by clicking on Dependencies, See All, and you'll be given this long list of options, OK? All right, I'm happy with my choices. I'm going to go ahead and hit Generate, and that'll give us a new project, a project that I'm going to open up in my IDE, and we're just going to go ahead and use that to demonstrate some of these concepts today. All right, so we have a brand new application, a Spring Boot application, and we're going to create a new application that manages data. It's going to persist the data into the database. And so we're going to create an entity, an ORM kind of like entity, that we're going to map to documents, that is to say, a single record in the database in MongoDB. And I've got MongoDB in the background here. And I'm going to use MongoDB to save data into the database. I'll say @id, @document, and that's my basic entity definition. But this is Java, and I still need getters and setters and all that kind of stuff. And so obviously, I could just getter and setter my way to production like that, equals, hash code, blah, blah, blah. So productive, so modern. Look at that nonsense. So instead of doing that, I'll use Lombok, right? Lombok is on the it's a compile time annotation processor. It's on the class path. And all I got to do is annotate my types, and I get the synthetic getter, setters, toString, equals, hash code, etc. With that, I want to create a repository. And a repository is an object that's going to let us handle the tedious, soul-annihilatingly boring read, write, and update and delete lifecycle, the lifecycle of data, okay? And so we've got this repository from Spring Data. It's a reactive CRUD repository. If we click on the interface, you can see that the methods are fairly straightforward. What's going to happen is Spring is going to create an implementation of this interface that supports these methods. We don't have to do anything more than the interface. These methods are straightforward. We have save all, find by ID, delete, check if it exists, count, flush. All these kinds of normal CRUD-style data management lifecycle manipulators are all there. These methods are straightforward, but the signatures, I suspect, might be a little weird for you. First of all, what is a publisher? Well, a publisher is a thing from the reactive streams. These are one of the 4 types that I just described to you in the reactive stream specification. A publisher publishes items of type T, where T is anything. It could be a single byte, it could be a byte buffer, it could be a string, it could be a customer, or an order, a line item, whatever. A publisher publishes an item of type T to the subscriber, and the subscriber consumes that item in the onNext method. So the publisher will have 1 or 0 or a trillion or an infinite number of records. And as they become available, it publishes them to the subscriber. The subscriber then consumes them in the onNext method when the data is available, if it's available. If there are any errors, then that error is communicated through the onError method here. This is to say that when you have an error in your processing code, you handle it in the same way with the same kind of operators as you would regular data. Errors, contrary to the Java language designer spec, are not exceptional. They don't require a separate control flow. They're just another kind of data. And so you are forced to confront that when you write reactive code. In this way, reactive code is a bit more functional than regular code. We also have the onComplete method, which gets called when processing has completed non-exceptionally. Okay? Now, I skipped over this most important of methods because I wanted to drill down on this and just spend a few seconds. This onSubscribe method is where we are given a link, a reference to the subscription. A subscription is the link between the producer and the consumer. It's how the consumer tells the producer to slow down. And we do that by saying, I want to request X number of records. If you specify long.maxValue, you'll be given an unlimited number of records. But if you specify anything less than that, then you'll be given as much as is available up to that point, right? So long.max value means give me as much as possible. If you've got 10, give me all 10. If you've got a billion, give me them all as fast as you can. If you specify X, then it'll give you no more than X. It doesn't matter how long. It might be X records over X years, or it might be X records over X nanoseconds, right? There's no stipulation there about what that means. And if you want to stop the production of data, you can cancel it as well. Now, this isn't a particularly controversial idea. We're telling the producer to slow down. We need to do this because there are discrepancies between the rate of production and the rate of consumption. This is something with which we've all no doubt been exposed, or to which we've all no doubt been exposed if we've had to build network protocols, right? If you've ever had to think about basic networking, you have to think about the reality of some things being faster than others. When you get that mismatch, when you get that sort of discrepancy, then things get bad, right? Things start to overwhelm each other. This creates unstable systems. This is why it's possible to denial of service certain kinds of protocols like HTTP. But this isn't like a new idea, right? If you've ever built network protocols, you've had to think about this. In the context of networking, from the moment we had one computer connected over a network to another, we call that flow control. It's a 60-plus-year-old idea, right? Not even close to controversial. We just call it flow control. In the world of reactive programming, of course, where everything that is old is new and has been rebranded by marketing, the word flow control has been turned into back pressure. Okay? So when you see the word back pressure, we're just talking about flow control. We're talking about having a way for the producer to ask, for the consumer to ask the producer to please slow down. Okay? Now, we've got these 3 types. I did say there are 4. There's a 4th type called a processor. And a processor is just that. It's a bridge. It's a source and a sink. It's a consumer and a producer, a subscriber and a publisher. And if you understand those 4 types, then you're already, you already made great progress. Congratulations. You're certified reactive. Go to Silicon Valley, start a new company, get millions in venture capital, start up and throw different terrible parties and burn out after 6 months. You're already halfway there. That said, there are some other types that support operations on these streams of data. These types include mono. Mono comes from reactor. This is not a reactive streams sort of type. This is one of our types from our project built on top of reactive streams. It's an implementation of publisher from the reactive streams. But a mono is a publisher that produces at most 1 value. It's like a completable future that is asynchronous and also supports back pressure. Okay, so at most it'll have 1 value. A flux, on the other hand, is a publisher, just like mono, but it's a publisher that produces 0 to n values, where n is potentially unbounded. It's like a Java 8 stream, but it supports back pressure. Okay? So now we have these basic types. We have these types with which we can work, and we have these interfaces. Now we can use that to write some sample data to the database. So I'll do that right here, sample data initializer. We're just going to create a bean that listens for events when the application starts up. Initialize. And we're going to initialize it by injecting a repository into our object here. And I'm going to use Lombok here to create a constructor for the required field. So I've just created a constructor that has an argument of type reservation repository. Spring will see that. It'll see that it can resolve this dependency by looking in the context, and it'll inject that reference for us. So there we go. We've got this. Now what I want to do is I'm going to create a publisher with some names in it. So I'm Josh. It's so nice to meet you. I've got some other names I'm going to add here as well. Let's see, Dr. Sire. I've got Violetta. I've got who else? Who else do we have? We've got Stefan. Good. We've got Olga, we've got Madura, and I need one more name. Sorry? Good idea. Sebastian, thank you. So there's some names, okay? We've got some names in our application. And I'm going to just turn this into like a hard-coded list of names. It's just a publisher with some names resident in memory. And what I want to do is I want to visit each one of those names and turn them into a new publisher. So a new reservation, rather. I'm going to write that reservation to the database, and I'll store that as an intermediate type of type reservation. So it's a publisher of reservations. And now I want to visit each one of those and turn it into an object that gets written to the database. So here's the reservation. Okay. All right. A new reservation that we're going to write to the database, reservation repository.save, passing in RE, and we're going to save that as another publisher. So what I've done is I've called flat map instead of map, and the reason is because save returns a mono, so it's a publisher of publisher is what I would get normally. If I used map, then this would actually result in a flux of mono of t, and that's one publisher level too much. Instead, I want just one level. So I could do this. I could say publisher like that, publisher. And that would be clumsy, right? It'd be hard to sort of navigate that if I used map. So instead, I'm going to use flat map, and I'll unpack that intermediate type. I'll unpack the result of the save operation. Okay, so there we go. There's my three levels, my three pipelines, and I want to run this code. If I ran this code right now, though, you would find that there's no data in the database, and the reason is because this stream, this pipeline, is cold. You have to activate it. You have to actually trigger the execution, and you do that by calling subscribe, which we saw earlier. So I could call subscribe like this, and it would work, and that'd be fine. But the problem is if I ran this code as it is, I would get the same data in the database after a few runs. You'd see the same data in successive runs. So what I want to do is I want to create one pipeline, but I want to delete everything first. So I'm going to say, first of all, I'll say this.reservation repository.delete all. That'll return a mono. So then I want to say, run this saved pipeline. And then I want to say, find all the data in the database, like this. And then finally, I'm going to subscribe and just use a consumer, a Java 8 consumer here, to log out the results. And I'm going to use the lombok annotation here to inject a logger field. So log for J, log info, new reservation. Actually, I can just log it like this. There we go. Now, we can turn this into a Lambda. Good stuff. Log that out. Turns it into a method reference. Good stuff. And I've got this whole pipeline. But in point of fact, you don't actually need to stage these different levels as separate intermediate variables. I just did that for our own reference so we could kind of follow the action here. But really, I've just got one pipeline, one stream here. So I'm going to create a publisher of type reservation called saved. And in fact, it's Java 11, so I can just do var. Okay, so there we go. There's my pipeline. And what I've done is I'm now going to write all the data after I've deleted everything. The deletion will happen before everything else. It's guaranteed to happen before everything else. And remember, these things can execute on different threads. There's no guarantee that what happens here happens on the same thread as this. And the reason is because there is a scheduler behind the scenes. I can exert control over the scheduler. I can say subscribe on, for example, subscribe on. And I can provide a scheduler like this, providing an executor service, right? Executors even. I can do that if I want, but I don't need to. In fact, I would recommend not doing that. If you find yourself doing that, you should only do it for interactions with blocking code, right? The reason is because by default, you're going to have one event loop per core. The scheduler will have one event loop for every core in the machine. That is to say, it'll be fine. As long as you don't sit there and block the thread, as long as you're doing your work and getting off that thread as quickly as possible, then the default configuration will work just fine. So let's see what happens if I run this program as written right now. All right, look at that. It worked. Huh? How about that? Of course it worked. It was a demo. What were you expecting? This was always going to work. This data was always going to work. What I wanted to talk to you about, as always, and the main reason I'm here, is because of this. This is the ASCII artwork in Spring Boot. This artwork took a long time to get right, but we on the Spring team have many people who are doctors, PhDs, people who in their previous lives worked in nuclear physics. And so it's for this reason that I want to take a brief moment to talk about what I consider to be a glaring and serious deficiency in the IntelliJ JetBrains product. For while I'm a fan, I consider this to be particularly short-sighted. Do you see this checkbox? This one right here. This one, do you see it? This one right here? This checkbox? Do you see it? Are you seeing this? Are you seeing the checkbox before you? This checkbox, once clicked, don't click it, suppresses the output of the ASCII artwork. What the hell? Why is this here? That's a dumb feature. Nobody even asked you, IntelliJ. So I did what all people would have done in the same situation. I'm not a hero. I'm not a hero. You don't have to thank me. I went on the internet and I cried. And I was sent a message of hope from my friend, Jan Sabran. This is Jan Sabran right here. This is Jan, right here. Boop. This is him. He's a software developer by passion at JetBrains. And he sent me this message of hope, which I share with you today. Or not. There we go. Slow clap. Now, he's a friend of mine. He's a friend of mine. And I want to believe him when he says that. I want to believe him that it's going to be real. But you know what? I'm starting to think that maybe, just maybe, he's not exactly on the level. I'm not sure why it's taken so long, but whatever. Anyway, the point is I've got data in the database. I've got my reactive application. That's all well and good. I want to build a REST controller to talk to the database. So I'll say reservation REST controller. OK. REST controller. And I'm going to inject my repository there, reservation repository. And I'll create an endpoint. I'll say at required args constructor to create to synthesize a constructor there. And I'm just going to create an endpoint that returns a publisher of all the data. Okay, so reservation, return this dot reservation repository, find all. Good stuff. And now if I restart the application, we'll see that it's spin up on port 8080. And I'll have an endpoint here, reservations, voila. Hello, come on. Did I miss something? There it is. So there's my data that's been produced for me in the reactive pipeline, okay? Now it looks like Spring MVC. If you've ever used Spring MVC, this should be very familiar. But it is not Spring MVC. And there are some subtle differences here. First of all, there's no servlet API here. This is built from the ground up on top of Netty, okay? We're not using a Tomcat or anything like that. And because of that, we can do some things that are fundamentally different. I'm returning a publisher. And everything, by default, is a publisher in Spring WebFlux. So even things that would have otherwise been sort of difficult to express because they're asynchronous and potentially unbounded, like service and events, even things like that become very easy to express in this brave new world of reactive streams. Okay? So I'm going to create a service and event endpoint. This is a content type of type text event stream that when the client sees it, it'll know to connect and then not disconnect. It'll just keep reading for the data. It won't ever disconnect, so it's very efficient. It's going to do polling on the client. And in order to do that, I'm going to create an ongoing stream of data. Okay, interval message producer, publisher of type string produce. And I'm going to say flux.from stream.generate new supplier. And the supplier is just going to return hello name at instant.now. And the string will be a parameter in the method here. And I'm going to stagger each production of elements. Each result that comes out will be staggered with delay elements. So there's my single component, my little service thing that's going to produce new greetings, okay? Greetings. Or better yet, I'll create an entity. I'll create some types, greetings request, private string name, okay, at data, args constructor, no args constructor, great, and class greetings response, okay? And that's just going to be a string greeting, good stuff. So there we go. Args constructor, no args constructor, good stuff. So I'll say, whenever somebody says, I want a greeting, I'll produce a stream of greetings responses, like so. Okay, so name.getName. And I'm going to turn each element in that stream into a new greetings response, like so. All right. So there's my little service. I'm going to use that here to return the data. I'll say greetings, a service and event stream of greetings responses. This dot, where's my interval publisher? There we go. Private final interval message producer IMP. Okay. And I'll say this dot IMP dot produce greetings, and the path variable here is a string. I'm going to say new greetings request, n, and that's it. So I'm just going to return that stream back to the client. It's a reactive stream, though. It's going to keep going. It's going to produce a new value every second. So we just have to go to the browser on port 8080 SSE/Josh, like that, and then we get a stream that produces a new record every 1 second. And as we're producing new records, we're not blocking the server. We're not stuck on that thread producing that new value. That thread is free in between the raindrops to handle other requests. So you can see that this makes life very simple, right? We have this very sort of reactive, sort of ongoing way of thinking about data. And the code is not much more complicated than in the case when we just had 8 records. It's the same metaphor. You don't have a completely different programming model. If you wanted to do WebSockets, you would just do the same thing. You'd create a publisher, right? That's all you have to do is to use publishers. If you want to do server-side events, you create a publisher. If you want to just return 8 elements of data, use a publisher. When you're not sure, use a publisher, right? That's a very simple way to think about it. Now, I have been using MongoDB, and I like MongoDB. It's a very nice example of a reactive driver. Our data support here is built on natively reactive drivers, okay? So this is not just a facade on top of existing synchronous blocking database abstractions. We are using natively asynchronous, natively non-blocking I/O underneath the hood here. And MongoDB is a good example of a driver that's done right. It takes advantage of reactive APIs, and it works nicely. If you want to do tailable queries, for example, in MongoDB, then that's nice. It's well supported. You can do transactions in MongoDB, and that's supported even in the reactive API that we built on top of that. So you have all the sophistication, but let's be honest, MongoDB is not the biggest game in town, right? I think most of us are probably using some sort of SQL database. Who's using a SQL database somewhere in your architecture? All right, so it would be weird for me to say, oh, just ignore SQL and all the decades of experience on that. And that's a very reasonable sort of response to the question of, or to the proposition of reactive programming. Something that people pose to me all the time is, how do I use a SQL database? And the answer up until now hasn't been great. It hasn't been very consistent because, unfortunately, most people are aware of JDBC, and JDBC is a synchronous and blocking API. So what we wanted to support was a non-blocking sort of approach for SQL data access that goes beyond what we understand with JDBC. By the way, before I move on, I should also mention that while I did this using Spring MVC-style endpoints, you can also do this using a functional reactive endpoint model that we've introduced in Spring Framework 5 that might be more your cup of tea, depending on what you like to do. So this same endpoint that I just created, I could have described using this as well. Okay. Route. Am I? Router function. Okay. Goodbye to you and you. So, router functions, route.get/reservations, new handler function, .build. And so you just return a lambda, and the lambda contains the body. And I'm going to create that body by using the reservation repository. I'm going to stipulate as much by saying it's a reservation type. So there's my rewritten handler function. And there's some different opinions about why you would use this versus that. I'll leave it to you to sort of explore. But the main benefit here is that we have this programmatic way of introducing functionality into the application. It's a builder, so you can actually dynamically add things to the router functions if you like. You can programmatically decide to register or not register endpoints. It's nice like that. Depends on your style. You can mix and match as well. There's no one way or another. Anyway, back to what I was saying. We have this MongoDB application. I like MongoDB, but it's not the only game in town, and we want to be able to support SQL. So at Pivotal, we have created a project called R2DBC, which is an open source abstraction that's designed to support not now. Sure, remind me later. What the? Okay, it's called R2DBC, and R2DBC is it's an abstraction that allows us to describe asynchronous, non-blocking database drivers for SQL. I mean, there's a number of different implementations that implement the ASCII. There's PostgreSQL, there's Microsoft SQL Server, there's H2, and there's even a third-party one supported by something called JASync that supports MySQL. So there's 4 so far. There are more coming. And of course, if Oracle's ADBA thing ever starts to get real, then we have a binder, an adapter that will work with that as well. So the point is, you can use R2DBC on top of anything that supports this kind of work. And you can use R2DBC in your application, but it's not yet GA. It's not finished. And because it's not yet GA, I want to caution you, I want to warn you, I want to advise you to regard it with the same skepticism, nay, tumult, nay, hesitation with that you regard something like PHP, right? Never the two shall meet. Never production and PHP should ever meet, right? This is production, here's PHP. Never the two shall come together. I want you to think about this R2DBC in the same way. And because it's not yet GA, and because it's not yet production worthy, I have to add the configuration myself. I have to do that manually. So I'm going to do that over here, desktop, misc, deps, R2DBC, PB copy, okay? So I'm going to add these dependencies. This is for PostgreSQL. I've got the dependency management section here. I don't need that. So I'm adding Spring Data R2DBC and R2DBC Postgres to my application, and I'm just going to drop out the MongoDB support. Here we go. Okay, goodbye. And now I need to rewrite my application to support this brand new world. The only things that are, the top level things that you have to do, I'm changing it from a UUID to a monotonically incrementing primary key in my database. And of course, I have to update the repository to reflect that. And in the not too distant future, there's no reason to expect that this wouldn't be enough. But for the moment, it's not enough. You need to actually configure R2DBC itself because there is no auto configuration in Spring Boot just yet, not yet, okay? So we're going to create a connection factory, like so. And that connection factory's job is to connect to our Postgres instance. And we're going to use a builder to do the hard work of configuring this. Now, normally you'd keep this kind of information in a property file, but hashtag YOLO. So here we are. OK, localhost, and database name equals orders. And there we go. There's my connection information. And you can see that this information is in MongoDB. You can see I've got UUIDs there. Now let's see what happens when I restart it. Enable R2DBC repositories. Good. OK, so now you can see I've got a monotonically incrementing primary key value there, right? ID equals, 238, 239, et cetera. So that's talking to a Postgres instance in the background, not to MongoDB. And you can see that here, psql -u orders, delete from reservation, okay? Select all from reservation. Good, nothing in it. Restart. And go. So there's my data in the database, right? So you can see I'm actually talking to a Postgres as well. So, we can now do interesting things. We can now talk to a good number of systems using reactive APIs. I've built an HTTP service. I like HTTP, and don't quote me on this. This might be a bit controversial, but I truly believe that HTTP has a future. It's going to be big one day. That said, it's not exactly a great application level protocol, is it? It's a great document retrieval protocol, but it falls short of application level concerns for a number of different use cases. Use cases that were, by the way, well supported 20 plus odd years ago, right? We actually had, in some ways, more freedom and more flexibility as developers, as engineers, back in the 80s, in the client server era, right? In the 90s as well. Things like fire and forget. How do you do fire and forget architectures? How do you say to the server, don't bother setting up the machinery to produce a response, I don't need it? How do you do server-side push, right? How do I initiate a discussion from the server to the consumer, from the producer to the consumer, instead of having it be request reply all the time? How do I do long-lived connections? One option might be service-send events, but service-send events is text-based. If you want to do any kind of binary data, you have to base 64 your image or your stream or whatever. It's not very efficient, right? What about WebSockets? Well, WebSockets are a bit better, but that is a separate protocol, first of all. And second of all, you don't have headers, right? WebSockets don't have the concept of a header. How do you do security, right? How do you propagate a token? These are basic, just super, super basic concerns that every application ever written will always have every time, and yet HTTP fails to address all of it, right? So it's a bit of a bummer because we have to add these things. We have to sort of fill in these very obvious gaps. And so one example for WebSockets is we use Stomp. Right? Stomp is a way of encoding the message header and the payload as part of the payload for the WebSocket. Right? It's a convention. And if both producer and consumer don't know about the convention, then it doesn't work. That's a bit of a bummer. And that's separate and apart from the payload of the Stomp message itself. So you've got two levels of contracts that need to line up before you can even agree on how to communicate using WebSockets. So these things are I think just a bit of a bummer. And like I said, there's other message exchange patterns like server-side initiated. There's request of a stream and response for a stream. There's request a single value and get a stream back. There's request reply with a single value in and a single value out. And there's fire and forget where you send a single value in, but you get nothing back. These kinds of interactions are natural to express using TCP and UDP, but they're not so natural to express using HTTP, which only supports one of them, request response. Not to mention, HTTP 1.x supports text-based communication, right? It's not binary by default. And so this is one of those things that gets fixed in HTTP 2, but you still have all those other limitations. The result is that in order to communicate binary data, you have to base64 encode it, send it back to the client, and then the client unencodes it. It's very inefficient because the data started off as binary in the first place. We just mule it across the wire as text to be able to use HTTP. So a number of different companies have faced these limitations and many others, and they've decided that while HTTP is great for the open web, it's not great for sort of homogeneous application level integration. Google very famously created gRPC. gRPC is a whole technology stack dedicated to solving and fixing some of these limitations in HTTP. It requires that you communicate everything in terms of Google protocol buffs. So that's a bit of a bummer as well, because you might want to use other kinds of encodings. And it's not by default reactive. It's asynchronous, but it's not reactive. Salesforce created a compiler plugin for Protalk, which is the gRPC compiler. They created a compiler plugin that will code generate reactor-based services for you, right? So they're using Reactor at Salesforce. They're using gRPC plus Reactor from Pivotal, right, to scale. There's another fairly big website that one day I think has a future, maybe, called Facebook. They're a cat picture site based in California that I don't know what they do, but the point is, apparently they're very popular, and they want to scale. So in order for them to scale, they hired a number of engineers, a lot of whom came from Netflix, and the team from Netflix that they hired in particular worked on RxJava, and they worked on the reactive stream specification. They went to Facebook, and they were trying to solve the problem of how do services communicate with each other. And so they created a protocol called RSocket. It's an open protocol, and it has a number of different implementations. It's a wire protocol that is natively reactive by default, out of the box. It has, in the protocol, ways to do different kinds of message exchanges. It's payload agnostic. It doesn't care whether it's text or binary or whatever. And it has concepts like headers, and it even has concepts like uptime. How do you communicate? How do I, as a server, as a service, communicate to my client my load, my uptime, my availability? If you're using Spring, then you've no doubt heard about the actuator. The actuator communicates this thing, but it's sort of a thing that we do by convention, isn't it? It's an out-of-band thing that the client needs to know to look for on the service, right? And that way they can figure out what's your availability, what's your uptime. If I make a request to you, will I get a response back? So we can use RSocket now. We have native support for RSocket in Spring, in Spring Framework 5.2, which is coming out this year. So what I'm going to do is I'm going to build a new client here. Okay, that's going to be client. I'm just going to use RSocket 2.2, Lombok, Reactive Web, and that's it. Here we go. Quick as possible. So the goal here is to make this as simple as easy and easy as possible. RSocket is payload agnostic, but it doesn't support routing, right? It doesn't know about routing. So in Spring Framework 5.2, we've got support for that. You can say add controller class RSocket greeting controller. Okay, I'm going to create a message mapping endpoint that does routing for you. This is Spring. And it's going to be a publisher, or a flux in this case, of type greetings response, greet, and it'll be a greetings request, okay? That'll be the payload request. And now RSocket is easy to integrate in Spring because, of course, the Facebook team that worked on Netflix wanted to choose a Java library to build their Java client, and it's only natural, I say, that they would choose, of course, Reactor from Pivotal. So they did that. And so it was very easy for us to integrate. So we've got this server-side thing. I'm going to say produce a greetings, taking in the request. So I'm just going to send back this reactive stream, this never-ending reactive stream. I'll send it back to the client as fast as I can. RSocket, here we go. It's going to be port 8000. I'm going to restart here. And on the client side, I'm going to create a very simple client that will just start up and produce the data. It'll stream the data back to the client using service and events. So I'm going to create a thing that uses Spring WebFlux, and then it in turn calls using RSocket. In order to do that, I need to create an RSocket object here. Okay. rsocket return rsocket factory.connect.data mime type utils application text value frame decoder payload decoder 0 copy transport TCP client transport. I'm going to talk on port. Which port did we say? We said port 8000. So port 8000 dot start dot block. Okay, there's my rsocket client, and I'm going to create a bean of type rsocket requester. This is the web client or the REST template, if you will, of rsocket from Spring. Okay, so we're going to inject this, and we say rsocket strategies dot rsocket client requester dot create, passing in this dot rsocket, passing in mime type application JSON, and passing in strategies. Okay. So there's my rsocket client, and all I'm going to do is I'm going to create a simple endpoint, an HTTP endpoint that's a service end event endpoint that's going to communicate the streaming data across the wire here. Okay, so at get mapping, SSE, greetings, name, and actually here static class greetings REST controller at controller and publisher of greetings response. I'm going to do something terrible, something that you should never ever do ever. I'm going to copy and paste some code. Here we go. Where is that code? Here we go. Go, go, go. Paste. There's my types so that I have those for communication. Greetings response greet. Okay. Return. And this is the type. Let's just clean this up a little bit here. Getting crazy. Good. Okay, so I'm going to use the rsocket requester, required args constructor, and I'll say this.requester.route greetings data, and the data that comes in will be the path variable that I'm going to turn into a rsocket greetings request, new greetings request, passing in the name, and n. And then the data that comes back will be a stream, right? So retrieve a greetings response dot class. And it's going to be a service end event just like before. So I'll say produces media type text event stream value equals this, and voila. Okay, so there's my name, there's my greeting request. I'm sending it to the server. I'm getting a stream back. I'm going to stream it back to the HTTP client. Okay. Oh, this will be on the wrong port. Server.port equals 8081, restart, go, go, go. Localhost 8081, and we call this endpoint SSE greetings n go to. No handler for destination greetings. What did I call it over here? Come on. There. Greeting. Santa Maria. So, greeting. All right. There we go, my friends. So you can see we used rsocket to communicate from one service to another. We did it in a binary way. It's super efficient. We don't have to worry about the communication. We don't have to worry about how it's encoded. In this case, it can be JSON, but it can also be protocol buffs or thrift or whatever. I hope you see that there's a lot of opportunities here and a lot of potential. I want to thank you so much for your time, and I want to encourage you to join me in my masterclass later this week. Thank you so much. GOTO, I appreciate it. Cheers.